Hello everyone. Let us now discuss how can we solve this problem. Sum of largest prime substrings. Given a string S, find the sum of the three largest unique prime numbers that can be formed using any of its substrings. Return the sum of the three largest unique prime numbers that can be formed. So we are given with a string and we need to return the sum of the three largest prime substrings. Now, if fewer than 3 exist, return the sum of all available primes. If no prime numbers can be formed, return 0. Now, a prime number is a natural number greater than 1 with only two factors, 1 and itself, right? 2 is a prime number, 3 is a prime number, 5, 7, 11. These are the prime numbers. Now, a substring is a contiguous sequence of characters with a string. Now, let us see how can we solve this problem, right? Here I have this string. Now, what I want to do is just take all the primes first. First, I am taking 2 here and then 2, 3, 2, 3 and also 2, 23 and 1, double 2, 3. So if I take these substrings and take the the three largest primes, those are here, right? 1, double 2, 3, 2, 23, 23. Now 3 threes are 9, 2 threes are 6, 2 twos are 4. So this will be the output. And if I see here, I have triple 1. 111 is not a prime number, it is reducible by 3. Now only prime number which is given or have in triple 1 is just 11. So we'll return the sum as 11. Now the thing is, how do we write the algorithm? So we need every substring, every substring. So for that, what I'll do is I is equal to 0. I'll iterate from I is equal to 0 and j is equal to I to n. Now I'm starting from I and going till j. So I need this substring. Now let me name it as string current is equal to s dot substring starting at where I am starting at I just need the size, then j minus I plus 1, right? If I and j are same, then I just need 1, the size of 1, right? Okay, starting at I and the size is j minus I plus 1. So if I have something like 1 2 3 and my I is here and the j is here, then j minus I is just 2. So I am starting at here until go to the size of 3, so j minus I plus 1. Now I got the current, right? But I want to store all the primes in an unordered set. So for that I need all the primes, right? Unordered set. Let me take in long unordered set long and name it as st, right? Now I have current as a string. Now long I need to convert it into number. Number is equal to string to long current. Now, if num is a prime number, then I'll insert that into the st. So, st dot insert num. So, this is how we solve this, right? But wait a second, it's not completed yet. We have all the prime numbers in our unordered set. Now what I'll do is take vector long vector long and name it as something like, let me name it as substrings. So these are the substrings, right? So I'm just taking that st dot begin unordered set dot begin and unordered set dot end. So all the elements from the primes, which are numbers, are taken into a vector. Now I have this vector, but I need to sort it in descending order. Descending order, right? So to sort that in descending order, I'll just use the sorting function sort substrings dot reverse begin dot wait a second, reverse begin and substrings comma substrings dot reverse end. So this will sort in descending order, right? I have it in descending order. And let me name size is equal to if 3 is less than substrings dot size. As I said, we need to take only 3 substrings dot size. If it is greater, the size of substrings is greater. Now we just need to take 3 as the size. Now if not, we will take substrings dot size, and I have that numbers in descending order, so from increasing from largest to the smallest. So for int I is equal to 0, I is less than size I plus plus, and don't forget to initialize uh, long answer is equal to 0 and answer plus is equal to substrings of I. At last I'll be returning answer. So this is how you solve this problem. And if we want to take the time complexity, here we are just taking big O of n square, big O of n square time complexity, and here we need to write is prime function. So in the is prime function, if I write the is prime function, bool is prime, wait a second, bool is prime long n. If n is equal to 1, then we'll be returning n is not a prime number, right? N is not a prime number. Now for long I is equal to 2 and I into I is less than n I plus plus, and if n mod I is equal to 0, then if n mod I is equal to 0, then return false. If not, we'll be returning true. Then it will be a prime number. That's how we solve this problem. If you like this video, do share to your friends and do subscribe to my channel. Thank you.